Now we're dealing with rational numbers in this video. Rational numbers, anytime you say that word rational, it pretty much just means fractions. Are you excited now? Fractions. So the first thing we're going to do with fractions, we're not going to do a whole lot. But what we're going to do first, we're going to simplify them, reduce them down to simplest form. What that means is we're going to reduce it down until there's nothing common other than ones in the top and the bottom. Now if you don't know, the top is called the numerator, and the bottom is called the denominator. And I'm going to do this the easiest way I know how. I'm going to think, what's the largest number that divides in both 12 and 15? That's the same thing as asking what's the GCD or GCF 12 and 15. Well, the largest number that divides in both 12 and 15 is 3. So what that means is I'm going to divide the top and bottom by 3. And what is 12 divided by 3? What's 12 divided by 3? It's 4. What's 15 divided by 3? 5. So 12 over 15 reduces down to 4 over 5. And that's all I'm doing. Let's come over here to 14 over 21. What's the largest number that divides in 1421? That number is 7. So I'm just going to divide both of those by 7. 14 divided by 7 is 2, and 21 divided by 7 is 3. Now multiply and divide in fractions. Two ways of doing this. You can multiply straight across and then reduce, which is what this says, or you can reduce first and then multiply straight across. So let's do some examples. Start with this one. Right here, give us more room to look at it. So you have 2 sevenths times 3 fifths. So what I can do is I can go ahead and multiply straight across. 2 times 3 over 7 times 5. And then multiply 6 over 35. And that doesn't reduce, so we're done. A way more interesting example is the next one. 7 ninths times 3 fourths. So watch this. I'm going to go straight across. And this will be the last time I write out all the steps, by the way. So what you can now do is do 7 times 3 is 21, and 9 times 4 is 36. But then I want to reduce that. So what divides in both 21 and 36, you may ask? 3 does. So I'm going to reduce that by dividing each of those by 3. 21 divided by 3 is 7, and 36 divided by 3 is 12. But notice here, this is a fraction. Anytime I have it in fraction form, I can go ahead and reduce it first if I wanted to. So I could have taken this step right here and reduced 3 into 9. See that? Because 3 goes into itself and 3 goes into 9. 3 goes into itself one time and 3 goes into 9 3 times. So some words I have to reduce, either at the end or at the beginning. In fact, what I really want to do is take the original fraction and recognize that that's one big old fraction. The original problem, that is, it's one big fraction, and reduce first. 3 goes into 3 once, 3 goes into 9 3 times, and then you multiply straight across, and you're done. And that's exactly what I'm going to do here. This is one big problem that involves multiplication, which means it's one big fraction. So I'm going to reduce first. Let's start with the 18. Now 18 does reduce to 15. You can reduce any numerator with any denominator because it's one big fraction. I can reduce 18 to 15 if I want to, but I don't want to because I want to reduce it with the 36 because 18 goes into 36. 18 goes in 36 2 times, and 18 goes in 18 one time. And then 15 and 25 reduces by 5. 5 goes in 15 3 times, 5 goes in 25 5 times. And then I still check to make sure there's nothing else that reduces, and there's not. So then I multiply straight across. 1 times 5 is 5. What is that? What happened there? Did you see that? Crazy. 1 times 5 is 5. And then 3 times 2 is 6. And that is by far the easiest way. And then we come to dividing fractions. And we're going to use the reciprocal. The reciprocal is just means you take the fraction and flip it over. Now, what you have here may not be what you want to see. This looks like it's cross multiplication, and it kind of is, but you don't want to do that. What you want to do is, you want to take this A over B, and times it by D over C. That's the best way of looking at it. That's how we got the AD over BC. We multiply by the reciprocal. Also, and what that means is you take the second fraction and you flip it over and multiply. And that's called keep, change, flip. Keep the first fraction, change the sign to multiplication. Keep the first fraction. I don't know what that is. It's supposed to be, I was going to write flip, but that's not good. Change the sign of multiplication. And then flip the second fraction. Always flip the second fraction. So let's do a couple of examples. So 2/7 divided by 3/5. We're going to keep the 2/7. We're going to change the division multiplication. We're going to flip the 3/5 to 5 over 3. And then we're going to multiply straight across because nothing reduces. We're now following the same rules for multiplication. 2 times 5 is 10. 7 times 3 is 21. Now in this example, take note that we have 18 over 15 divided by 25. And there is a denominator there. If you don't see a denominator, it's always 1. So now we can do keep, change the multiplication, and flip. Now you gotta ask yourself, does anything reduce? Well, 18 and 25 doesn't reduce, but you know what does? 18 over 15 reduces, because both of those are divisible by 3. So I'm going to go ahead and reduce those. So 18, which I'm not going to do it like that because I prefer to do it all in one step. But we are dividing by 3, so that means 3 goes in 18 6 times, and 3 goes in 15 5 times. And then you multiply straight across. 6 times 1 is 6, and 5 times 25 is 125. Not bad, is it? But watch this. Something you may not be aware of if you happen to have a graphing calculator. It will reduce 12 divided by 15. If you hit math, which is a fraction, enter, it reduces it for you. It also multiply for you. Like 2 divided by 7 divided or times. Put the fraction in parentheses, both of them. And then if you hit enter because you forgot to hit fraction, it doesn't matter. Just hit math, enter. It'll still give you the answer. And then this last example, 18 divided by 15 divided by 25, math, enter. And it gives us that 6 over 125 that we already found. Now the reason why I do it by hand is because later on in this class you'll want to do it by hand. It's just going to make life a lot easier and be easier to understand. And that's it.